Hello, here we're going to be solving system of equations by addition method or elimination method. So the first step would be to align everything having x, y on the same side of the equal sign and have it equal to a constant on the other side. The goal would be to have one variable to add up to 0 or get eliminated. You will be choosing the variable you will be eliminating. So you will be multiplying rows by useful factors that will make one of the variables add up to 0. Once the coefficients of the variable you want to be eliminated adds up to 0, you will add rows and solve for the remaining variable from there. You can repeat the steps for the other variable or use substitution method to get the second solution. Here we have to solve negative x plus y equals to negative 3 and 2x minus y equals to 6. We have row 1 and row 2. Notice that in row 1 we have positive y, which is positive 1y, and in row 2 you have negative y, which is negative 1y. The coefficients of y are additive inverses already. Since our like terms are aligned, we have x's in the same columns, y equal sign is aligned, and constants are on the other side of the equal sign. What we can do now is add row 1 and row 2. So this will give us, we have negative 1x in row 1, we have negative 2x's in row 2, plus we have 1y in row 1 minus 1y in row 2 of y equals to negative 3 plus 6. Negative 1 minus 2, we have negative 3x plus 1 minus 1, 0y equals to negative 3 plus 6, 3. So the whole goal was to have one of the coefficients being equal to 0 because 0 times anything multiplies into 0, so y variable will disappear. So we get negative 3x equals to positive 3. Since x is being multiplied by negative 3, the opposite would be to divide by negative 3. Whatever we do to one side, we want to do the same thing to the other side. And we get x is equal to negative 1. And this is part of our solution. You can absolutely plug this into one of the original equations to get the y variable. So right now we have x is equal to negative 1 and we need to find y. Now it's absolutely okay to use substitution to find the other variable. And I'm going to use equation from row 1 because it has y variable with the best coefficient of 1. We had negative x plus y equals to negative 3, and instead of x we're going to use negative 1. So we have negative x plus y equals to negative 3. And we got x was equal to negative 1. So now we have negative times negative, positive 1 plus y equals to negative 3. Now we can solve for y. We are adding 1, so the opposite would be to minus 1. Whatever we do to one side, we want to do the same thing to the other side of the equation. This adds up to 0. So we have y equals to same sign sum, and the sum would be negative 4. And we have our second value, negative 4. It's always a good idea to check. So let's check row 1. We had negative x plus y, and it was equal to negative 3. We had x was negative 1 and y was negative 4. So we get negative times negative, positive 1, positive times negative, negative 4 equals to negative 3. We have different signs, difference, more negatives. So the difference between negative 4 and 1 would be negative 3 equals to negative 3. It's a true statement. Let's check row 2. We had negative 2x minus y was equal to 6. We found x is equal to negative 1, y is equal to negative 4. So now we have negative 2 times negative 1, positive 2, negative times negative 4 plus 4 equals to 6. And 2 plus 4 is 6 equals to 6. This is a true statement. So negative 1, negative 4 is our solution. Here we have to solve 2x plus 3y equals to 1 and x minus 2y equals to 4. So let's call this row 1 and this row 2. I'm going to begin with eliminating y variable. Notice that y has a 3 and negative 2 as coefficients. They have opposite signs. Both 3 and 2 will go evenly into 6. So we're going to eliminate y variable by creating additive inverse of 6. So I'm going to multiply row 1 by 2. In row 1 we had 2x plus 3y and it was equal to 1. So now I'm just going to multiply each term by 2 times 2 times 2 times 2. And in order to get negative 6y in row 2, I'm going to multiply each term by 3. So we have the original equation was x minus 2y and it was equal to 4. And let's multiply each term by 3 times 3 times 3 times 3. So the first row will simplify into 2 times 2x will give us 4x plus 2 times 3, 6y equals to 2 times 1, 2. And the second row will simplify into 3 times x, 3x, negative 3 times 2, we have negative 6y equals to 3 times 4, 12. So our scaled row 1 is 4x plus 6y equals to 2 and row 2 is 3x minus 6y equals to 12. Now that we have 6 and negative 6 additive inverses, we add columns, we add like terms. So we have x variables 4 plus 3. For y variables, we have 6y minus 6y, which is just equal to 0. That's what additive inverses do. That's what elimination does. It eliminates one of the variables. And we get 2 plus 12 on the other side. So now we have 4 plus 3, 7x equals to 2 plus 12, 14. To solve for x, we just need to divide by 7 on both sides. And we get x is equal to 2. And this is part of our solution. X value is equal to 2. In order to find y value, we can eliminate x variables or use substitution to find the other variable. I just want to go over elimination once more. Notice that in row 1 we have positive 2x's and in row 2 we have positive x by itself. What I'm going to do is just take row 2 and multiply everything by negative 2. So I'm going to keep row 1 as is, 2x plus 3y and it was equal to 1. And in row 2 we multiply everything by negative 2. Negative 2, negative 2. Make sure you multiply each term. For row 2 we get negative 2 times x, negative 2x. Negative times negative, we get a plus 2 times 2, 4. Y equals to negative 2 times 4, negative 8. Now that we have additive inverses in row 1 and 2, for x, we add 2x minus 2x. This adds up to 0. That's the whole point of elimination. Then we have plus, we have 3y's in row 1 plus 4y's in row 2. And it's equal to 1 minus 8 on the other side. 3 plus 4, 7y equals to 1 minus 8, negative 7. And in order to solve for y, let's divide both sides by 7. And we get y is equal to negative 7 divided by 7, negative 1. Our point is x is equal to 2 and y is equal to negative 1. And before I commit to this solution, I'm going to check. In row 1 we had 2x plus 3y and it was equal to 1. We have x is equal to 2, y is equal to negative 1. 2 times 2, 4. 3 times negative 1 minus 3. Is that equal to 1? 4 minus 3 is 1 and it is equal to 1. That's a true statement. In row 2 we had x minus 2y and it was equal to 4. We have x is equal to 2, y is equal to negative 1 and we get 2. Negative 2 times positive 1 plus 2 equals to 4. 2 plus 2 is 4 and it is equal to 4. That's a true solution. 2, negative 1 is a solution for this equation. Here we have to solve 5x minus 15y equals to 9 and negative x plus 10y equals to 1. So let's call this row 1 and this row 2. We have a positive 5x in row 1 and negative x in row 2. So the most efficient way of doing this would be to take row 2 and multiply each term by 5. So row 1 would be 5x minus 15y equals to 9. Row 2 would be the original equation, which is negative x plus 10y equals to 1, and we multiply each term by 5. So now we get row 1 is still the same, which is 5x minus 15y equals to 9, and row 2 will be positive 5 times negative x, negative 5x, then we have 5 times 10 plus 50y equals to 1 times 5, 5. Once we have additive inverses for x variable, we can add 5x minus 5x, that adds up to 0. We have 50y minus 15y, that gives us positive 35y equals to 9 plus 5, 14. So we have 35y equals to 14. Y is being multiplied by 35. The opposite would be to divide by 35. Whatever we do to one side, we do the same thing to the other side, and we get y is equal to 14 out of 35. Numerator and denominator can be divided by 7, and we get y is equal to 14 divided by 7, 2. 35 divided by 7, 5. So our y variable is equal to 2 out of 5. Since this is a fraction, I do not want to use substitution to find the other variable, because when it comes to fractions and systems of equations, addition method is easier. If we want to eliminate y variable, we know that 15 and 10 are easily divisible into 30. So we can take row 1 and multiply everything by 2. We had 5x minus 15y equals to 9 in row 1, and let's multiply everything by 2, each term by 2 times 2 times 2, and we can multiply row 2 by 3. 10 times 3 gives us a 30. Negative x plus 10y, it was equal to 1. So let's multiply everything by 3. Our new set will be 2 times 5, 10x, minus 2 times 15, 30y, equals to 9 times 2, 18 for row 1, and negative x times 3, negative 3x, plus 3 times 10, 30y, equals to 1 times 3, 3 for row 2. Once we have additive inverses for y, we can add row 1 and row 2. So we get 10x minus 3x, 7x, plus 0y, or 0, equals to 18 plus 3, 21. So 7x equals to 21. Out of 7, we get x is equal to 3. And this is second piece of our solution. I would like to check my work. Row 1 was 5x minus 15y, and it was equal to 9. We got x being equal to 3 and y was 2 out of 5. 5 times 3, 15, minus this 15 is out of 1. 5 goes into this 15 3 times. So 3 times 2 equals to 9. So we get 15 minus 3 times 2 is 6. Is that equal to 9? 15 minus 6 is 9, and it is equal to 9. So that's a true statement. Let's check row 2. We had negative x plus 10y, and it was equal to 1. X was 3, y was 2 out of 5. So we have negative 3 plus 10 is out of 1. 5 goes into 10 2 times. So plus 2 times 2, and it's equal to 1. So we get negative 3 plus 2 times 2 is 4. Is that equal to 1? 4 minus 3. 1 equals to 1. And that's a true statement. So 0.32 out of 5 is our solution.